The different colors in the pie charts represent different lengths of the genetic marker in that specific sequence. So we compared 7 of my DNA sequences with 19 different populations around the world.
You, Bill, are always colored red and yellow.
I'm red and yellow.
You're always red and yellow. So you have a length that corresponds to red, and you have a length that corresponds to yellow. So your task is to decide which population you are the most similar to, knowing that you have a red and you have a yellow.
Okay, so this is just, I could be anybody.
You could be anybody.
Okay. We got a little red there, not so good here, but none of these are, actually, on this, that's pretty red.
That's redder.
It's a pretty complicated rig, isn't it?
That's the way evolution is. You know, it doesn't have intent.
Yeah, so
it happens and then it selects.
It's hard to believe that as obvious as you might think race is, when my DNA is laid out next to the rest of the world, it's very difficult to see where I'm any different from a Bantu or a Chinese person.
So you have picked, Bill, Sardinians.
That island out there in the Mediterranean.
Right.
Okay.
Japanese.
Uh-huh.
And
Algeria.
Algerians.
Of course I have.
Well, that's pretty reasonable, Bill. Here are the French. You did not pick the French.
Did not pick the French. I started to.
Well, what have we learned from this, Bill?
That you can't tell.
You can't tell with 7 different DNA segments, can you?
Well, how about this? I can't tell visually using these charts from 7 different DNA markers.
I don't disagree with your choices at all. It's, if we had determined your sequence at, say, 400 markers, then I think we would have had more information. But what this says to me overall is that those features of race that we're all very good at picking up, you know, skin color and hair color and eye shape and eye color, which are certainly genetic, are absolutely real, but they're not representative. These are representative bits of DNA. And these bits of DNA are absolutely shared, population to population. 93% of the entire world's variation you find in every population. If we compare 2 Africans by any measure except skin color, we'll find as much variation between 2 Africans as we will between someone from Africa and someone randomly selected from somewhere else in the world.
From Japan.
Sure.
Right.
Skin color is determined by a sequence at a gene called the melanocortin receptor locus. Humans have this sequence. Cows have this sequence. Mice have this sequence. Mammals generally have this sequence. Cows vary in skin color and consequently in fur color, just like humans do. Cows do not care.
Cows don't judge each other based on the color of their cow hides. No, why is that? Because they're cows. They're all the same species, and they know it. Or they act like they know it. Hey, you're not going to meet a cow racist. It's not going to happen. See, they're just cow friends there, enjoying a meal together. You know what? Maybe the cows don't overthink it. Maybe that's it. What does all this variation mean about race?
To me, it means that people vary enormously from each other, and that the great majority of that variation is shared by everyone. And that the features that we can easily detect when we look at people from what we call different races are important but extremely superficial features based on a very small number of genes that have been selected during human evolution. That as soon as we look beyond those, there are no archetypes that separate people from one continent of origin from another.
A long-distance phone call to an old racist buddy, $2. Refreshments for a white power meeting, $10. Explaining to a racist that all people have the same genes and that our external appearance, which is used to classify us into races, represents only 0.01% of our genes. Priceless. Telling a racist that we all come from Africa, really great. So what is
what people call race.
There is absolutely not any such thing as race, because race, you can see, is based on superficial things like skin coloration that can evolve more than once for good environmental reasons. Race is a most unfortunate social construct. There's no biological basis to this whatsoever. Unfortunately, it has a basis in our cultural discrimination against other groups of people. And that varies from one country to another depending on its history. When you begin to understand this, like you begin to understand the evolution of skin color, all of a sudden, the fallacy of this concept becomes transparent. And you realize this is entirely meaningless.
Jackie Robinson looked different from Pee Wee Reese, but they were both Brooklyn Dodgers. So if race isn't biologically determined, what is it? Well, the world used to be small. We were one tribe. Then the world got big. Our tribe spread out, ultraviolet light changed our skin, and we found things to fight about. Well, now it turns out we're still all the same. We're still one tribe, one race, the human race. See, race is a social construct, and it's something we can deconstruct if we choose to. See, the more we learn about each other, more we'll share, and the more we'll have in common. That's the way I see it, and I'll see you next time on The Eyes of Nye. Go around the world.
The Eyes of Nye. The Eyes of Nye.
We've covered a lot of ground, but it's just the tip of the iceberg. Check out eyesofnye.org for more cool science.